So now we're going to move on to APES review worksheet number 3. The first one is just looking at a whole bunch of different nitrogen compounds, and they're listed here. I don't know how important it is to know every single one, but and a couple of them are listed twice, but let's sort of look at it. So we have gases like nitrogen monoxide, and then a nitrite ion. So something with a charge is an ion, and that would be important to the nitrogen cycle. Nitrogen dioxide, nitrogen gas, which is the big store of nitrogen in the nitrogen cycle, so nitrogen in the atmosphere. Ammonium ion, which is that NH4 plus. We use that symbol of NOx to mean any sort of nitrogen oxides. Nitrogen dioxide is listed again. NO3 minus is a nitrate ion. And then we have dinitrogen monoxide. NH3 is ammonia, which doesn't have a charge. And one of the important things to recognize is things like HNO3, which is nitric acid. Things that are acids start with hydrogen. Looking at the next one, you want to sketch a house that is designed to make the greatest use of passive solar energy. So not looking at solar cells, but looking at just how the sun is shining in. And so if you want to make use of passive solar energy, you want the sunlight and warmth to be able to enter in the winter, but then to be able to protect it from the sunlight in the summer. So the shape of that roof is unique to making that happen. So windows are facing south or southwest. There's a floor where you can see that it's bringing in some different heating coils that are being heated from panels on the roof that are not solar voltaic panels, but just heating water, which is then pumped through the floors. Different things like planting trees on different sides of the house to protect sunlight from getting into the house. But basically maximizing that sunlight use is what we're going for there. So 3 is using the information from the diagram on the left. Go ahead and answer the following. So what is the percent change in per capita, per person, global production of protein on poultry between 1980 and 2000? So you have to find poultry on the graph. You have to look at what it is in 2000. And in 2000, it was 25 pounds. Compared to in 1980, it's about 13 pounds. And then you divide by the original. So our final minus initial over initial. So 25 minus 13 is 12. 12 divided by 13 is 0.923. Then you have to go ahead and multiply that by 100 to get the 92.3%. 3B asks you to sort of look at the same thing when we're looking at farmed fish between 1980 and 2000. So if we look at the line for fish, in 2000, it's about 12. In 1980, it's about 2. There would be some wiggle room depending on how you read that graph. So 12 minus 2 equals 10. 10 divided by 2, which is that initial, is 5 times 100 gives us 500%. It really, really increased. And then beef between 1961 and 2009. Beef is pretty much the same. So I did 21 for 2009 and then 20 for 1961. And then divided by 20 gives us a 5% change. The founder of the Sierra Club was John Muir. Rachel Carson wrote the book Silent Spring to raise people's awareness about the harmful effects of the pesticide DDT. And the acronym ENSO refers to the El Nino Southern Oscillation, which is something that occurs in the Pacific Ocean off the coast of South America. We want to remember that. Put these in following 9 events in chronological order, beginning with the most recent. If there's an event here that doesn't sound familiar to you, hit the Google and take a quick look at what it is. I know we've mentioned a lot of these in class. So the Deepwater Horizon was in 2010. The Kyoto Protocol was signed in 1997. The Exxon Valdez, 1989. The Montreal Protocol was right in the beginning of 1989. Chernobyl happened in 1986. Bhopal disaster was in 1984. Love Canal was in 1978. The Endangered Species Act came into effect in 1973. And the first Earth Day was in 1970. Question 8. We want to strengthen this weak statement that says fossil fuel use releases carbon dioxide, which causes the greenhouse effect. It's not wrong. It's not incorrect. But this is going to be really important as you are quickly writing answers on your AP test. So we're looking to take those weak statements and make them much stronger statements, because a much stronger statement demonstrates your knowledge better. And I think that's what we're going to really focus on after spring break, is how do we take these weak statements and make them into strong statements? Because I know you know the content. Now it's just a matter of making sure that the readers know that you know the content. So let's change it to the combustion of fossil fuels. So it's the burning that's the important part. Releases ancient carbon. So the important part is that we're not putting new carbon into the atmosphere, but this carbon that's been sequestered in the form of carbon dioxide, because that's the one that's going to cause the greenhouse effect, which increases the total amount of carbon dioxide in the atmosphere. So the net amount of carbon dioxide is increasing. This, in turn, increases the warming of the planet by the greenhouse effect. Much more complete knowledge demonstrated in that statement. And I know you know that. I know you can do that. So it's going to be a matter of skill to make sure that we are using those stronger statements when we write. The acronym BOD refers to biochemical oxygen demand. And that is the amount of dissolved oxygen a quantity of water uses over a period of time at a specific temperature. Things to remember: that low BOD is less polluted water, and high BOD would be more polluted water, because once we have some of those pollutions in there, either from fertilizers or from manure, that's going to upset the balance of that stream. The acronym GMO refers to a genetically modified organism, which is organisms in which the genetic material has been altered in a way that does not occur naturally by mating and or natural recombination. Here's some math again. So we did this way in the beginning of the year. If the grass is on a 100-hectare area of grassland, grow at an average rate of 1 centimeter a day, the average volume of grass that is added to the grassland each day is, and so let's go ahead and look at that. What I did here was 100 hectares, and 1 hectare is 10,000 meters squared. I would think you would need some of that information there. But basically, that gives me 1,000,000 meters squared. So let's take a look at what it says. It grows as our average rate of 1 centimeter per day. So I'm going to take this, my 1,000,000 meters squared. I'm going to change this to meters instead of a centimeter today. So 0.01 meters per day, which means that I'm going to have 10,000 meters cubed per day. That's where that first answer comes from. If the density of the grasses that grow in the grassland average 400 kilograms per meter squared, the net primary productivity is approximately what? So let's take a look here. We're going to take this 10,000 meters cubed per day that we had, and we'll multiply it by the 400 kilograms per meters cubed. And knowing that there's 1,000 grams in a kilogram, this is how many grams I have per day. And obviously scientific notation would be fine here. But this is from this number up here. This is my 1,000,000 meters cubed. So really I have 4,000 grams per meters cubed per day. And if I wanted to extrapolate that to years, there's 365 days in a year, and that's where this number comes from, because I multiplied it by 365. Kind of a tricky math problem, but it's all unit analysis. And so if you keep that in mind when you're working on your test, if there's a math problem, unit analysis is going to be a key way to solve any problem.